our last conic section that we'll learn about, which are hyperbolas. Hyperbolas were the ones that were formed when you cut straight through that double-neck cone to create like two parabolas, basically. And so, just like with the other conic sections, you guys are going to be able to analyze, graph, and write equations of hyperbolas. This is a heads up. There is a test coming up. It will be the last test for the quarter. And you guys will get your review on Friday. Okay? So, hyperbolas. Okay? A hyperbola is the locus of all points in a plane such that the absolute value of the difference of the distances from two foci is constant. Okay, so unlike the ellipse when it was the sum, okay, of the distances from the foci, hyperbolas are the difference here. Okay? Now the graph of a hyperbola consists of two disconnected branches that approach two asymptotes. Okay, so as you can see in this picture, the blue represents your hyperbola. And so you basically have two disconnected branches. So those two looking parabolas are called branches, and they approach your asymptotes, which are, of course, dotted lines that a curve get really, really close to, but not cross or touch. The midpoint of the segment with endpoints at the foci is the center. Okay? So when you take the midpoint of the segment that connects the foci, you get the center. And the vertices are at the intersection of this segment and each branch of the curve. Okay? So you're basically going to have two sets of vertices, two sets of foci, and this time you're going to have two asymptotes. Okay? So each conic has their own type of different characteristics. Now, you have two axes of symmetry. You have what's known as your transverse axis. That is the length of 2A and connects the vertices. Okay? So your transverse axis would be this here. And you also have your conjugate axis, which is perpendicular to the transverse axis and has a length of 2B. Okay? So that's how you know what A is associated with and what B is associated with to help you when it comes down to writing equations, graphing, so on and so forth. Now the relationship between A, B, and C is a little bit different from the ellipse. It's still that C squared equals A squared, but this time it's plus B squared, so standard old Pythagorean theorem. Okay? So the relationship between A, B, and C is going to basically be Pythagorean theorem. All right? And here's an example of the two different types of hyperbolas that you can have. You can have ones that have a vertical type of orientation, where your hyperbolas are going to be up and down. And then you have your horizontal orientation, where it's going to be left and right. Okay? Now this rectangular box that's on the inside, that right there is basically serving as your, to assist you on where exactly your vertices are located. As well as to, kind of help guide you when you have to graph your asymptotes. Okay, so you will be graphing asymptotes here when you're graphing hyperbolas. All right, and honestly, when you graph them, I'm only going to be looking to see, okay, where's the vertices, where are the foci, and then pretty much I'll, make sure you don't cross the asymptotes when you graph. Okay, so it's not like you're going to have to find multiple points on the hyperbola to graph it. It's more of where's the vertex, you have the asymptotes drawn, draw your two branches. Okay? So here's some key information that you need to know. Okay, follow along with me as I explain this. Okay? First, we'll start with the standard form of the equation. Very similar to an ellipse. There's a few differences. First off, for a horizontal transverse axis, you have x minus h squared all over a squared minus y minus k squared all over b squared equals 1. One key difference compared to an ellipse, what's one difference that you see? This one's a minus, and the ellipse was a plus. So that's going to be one way to identify which conic is which. When if I ask you that type of question, you have to complete the square to do that. So if you have a minus, if one of your square terms is a minus, then you know it's going to be a hyperbola. For the ones that have a vertical transverse axis, this time your a squared and your b squared stay where they are. It is your y minus k squares and your x minus h squares that change. Okay? So you'll know which one it will be depending on which one is negative. Okay? If your x's are negative, then you know it's going to be a vertical hyperbola, meaning that it's going to open up and down. But if your y's are negative, then you know it's going to be horizontal and they're going to open to the left and to the right. Okay? Questions? Yes, but you gotta be careful. Make sure you also look at the sign. Okay? Now, your foci is still associated with C. Okay? So you're gonna have two foci. So it's gonna be H plus C comma K and H minus C comma K. If it opens horizontally, because again, horizontal means it affects your axis. And then for your vertical ones, it's going to be H, K plus C, and H, K minus C. Probably should use different colors. All right. Your vertices. Okay, and again, these are mostly for the ones who are formula-based folks, you know, ones that are not so visual. Okay. Your vertices are still affected by A. A affects your vertices. So it's going to be H plus A comma K and H minus A comma K. So whatever your center is, you do add A to your X values. If it's horizontal, but if it's vertical, then you add it to your K's. And hopefully, but at this point in time, you know that H and K stand for your center. Okay? The length of your transverse axis is going to be 2A. It doesn't matter if it's horizontal or vertical. Okay? It's going to be 2A regardless. And the length of your conjugate axis is going to be 2B regardless of whether it's a horizontal or vertical hyperbola. Okay? Lastly, your asymptotes. Okay? The equation of your asymptotes are as follows. Okay, if you notice these are in point slope form, not slope intercept form, you have y minus k equals a plus or minus, because you're going to have two asymptotes. One that's going to have a positive slope, one that's going to have a negative slope. For horizontal, it's going to be b over a, x minus h. So whatever b is, whatever a is going to be b over a, and that's going to be the slope for a horizontal hyperbola. But if it's vertical, it's y minus k equals plus or minus a over b, x minus h. Okay? So this time it's going to be a over b. And these are the components of key information to represent your hyperbolas. Are there any questions before we jump into the examples? Okay, question?
Okay, is there like an equation like ellipses where it says like y equals k or h?
For your ellipses, when we were trying to figure out the equation of our major and minor axes, it was the equations, y equals k, x equals h, so on and so forth, okay? However, for your hyperbolas, you won't have anything like that. The only equations that you'll have are the ones for your ellipses. I mean, not your ellipses, wow. Your asymptotes, okay? The ones for your asymptotes. All right, so this is definitely, I would say this is definitely something that you would need to know, okay, and be able to distinguish which one goes for a horizontal and which one goes for a vertical, okay? So, let's look at some examples.